Hello everyone, I'm Xiaogang. Now let's analyze the started. First of all, how do we judge? We must ensure that our state is the init state. Why? Because this state must be. Since we are here at the very front, we can turn all of these off first because they are not needed for now. Ignore this for now. Then at the very front, we need to go up further. Here, let me take a look. Here we set it to this init state. Let's turn this off too. Turn off this comment. Okay, hide this as well. We haven't written this yet. Then, when we actually connect to it, we are here. Then we must equal this state. If it does not equal this state, it means there is an error in our internal code. This situation is problematic. It might involve you toggling it multiple times. This is a coding error. If it does not equal it, then we need to log a message here. And the severity of this log is quite high because I don't know why this error occurs, but obviously this thing should not have errors. So we need to output a relatively severe log warning here. Okay, of course, after the serious knowledge warning, we will still go ahead and prepare such an information. Then we put our parsed data here. But the most important thing is to return this stop. We can flip this over. This is to let the printer know that an error has occurred on our end. This is an unknown program error. This place is quite special. We need to force it to close. Let's put 30 here. Okay. This is using a force shutdown. Because this error is quite strange. This is something we need to control during development. Then, next, if it should be equal to this initialization, then now we convert it to this communication state. This communication state. Okay, in the communication state, what work do we need to do? First of all, we definitely need to get our audio, capture this subsystem. We haven't written anything for this subsystem, so in this lesson, we need to write it. Then this subsystem should be this. It is it. Okay, here, using the method of obtaining the subsystem, it's relatively simple because we are currently inside the subsystem. We can get our instance. Then, through the instance, we get the subsystem. Then here we get our capturing device. Okay, the code here, we need to write it in our try when writing in AudioCaptureSubsystem. Let's switch over here first. Okay, this is our AudioCapture system. We won't worry about anything like that for now. We'll keep our method protected. Okay. Why does it need to be protected? It's because of this reason. It's also because we want to avoid some users or developers using our stuff without knowing how to use it and without understanding why it should be used that way. But they see there's a method they can use, so they use that method. Then in the end, they run into a bunch of problems and blame it on your code. That's really frustrating, you know? So we just made all of it protected. It's made clear. I don't want you to use this thing, just to avoid some potential issues. Okay, here we first prepare a static method, because in this place, using the static method is for convenience, to make it easier for us to use. We don't want to get it through Subsystem, because we already clearly understand the life cycle of this Subsystem. So when we use it, it is relatively safe. So we don't really want to have to go around every time to go through the trouble of getting this word context. Object, that would be too troublesome. So here is our PTRZ2, a pointer. Then what do we do next? First of all, we definitely need to enable the audio stream and capture the audio stream. Let's put it here. We'll prepare two methods. To be precise, let's prepare 4 methods first. Let me paste them over for you. You don't need to worry about the parameters here. Okay, so this one is obviously for enabling. This one is for disabling. And this one checks whether it is currently capturing, right? And this part gets the currently captured device. Then we need to include these two modules in the header file. Include this header file, the educapital module. Then what is this? What is this struct? This struct, we can see that. Let me explain this educapital plugin to everyone. This is educapital devil information. This will capture your current microphone input device, its device name, whether its input channel is mono or multi-channel, and the sample rate of its input device. So, what does this correspond to? It corresponds to this thing. It is this thing. This mono channel corresponds to here, and this 48K corresponds to here. It is usually 16-bit. You don't need to worry about this. So this device, this struct is meant to describe this. Then we mainly use this AudioCapture. As for AudioCapture, it can capture, then stop capturing. Then whether it is in this process of capturing audio, and then this is called getting the current device information. So we mainly use this object. This is quite simple, right? You see. Then here there is a BP library. It is to create such an audio capture. You can see. Then inside it, it will itself leave an object. And then it tells that this audio, default audio stream. Then if it fails, it will return a null pointer. That's roughly how it's done. Then here are some module information. It does some configuration. Some loaded information. You can specify some related such parameters here. You see. Good. Okay, and basically that's about it. And there are some other methods here. You see, and this is a component of EduCapture. You should have seen this component in Blueprint, right? If you use the engine's native way to capture the Blueprint way, then it should look like this. Good. So simply take this field acquittal with export red and such. Everyone can tell at a glance, right? And if you're interested, let's take a look at the underlying layer together. The reason we use it is mainly because this thing is cross-platform. So we need to use it. So these four methods actually correspond to what we just saw. These four methods. Then we will create all four methods. Okay? Then next, we'll write a simple implementation of it. First of all, we need to prepare a pointer. That is to check whether our current EduCapture object exists. We need to attach a uPoverty house. The house has been garbage collected. Then, when we start the audio capture stream, if this object is, that is, if this object exists, then we first need to call the StopCapture method. That is to turn off this audio. If it exists, we need to do it this way. Then, what should we do here? Let's write the stop part first. It's also not a problem. If this thing exists, we need to set it to null. And there is a delegate here. We haven't written it yet. We'll write it later. So if it exists, we will stop capturing and set this thing to null. If it exists, we do this. Then after setting it to null here, we need to ensure this place is empty. Then we create a new one at this point using the method we just saw. We do this through this blueprint. This PP library approach will create an audio capture stream. This audio capture stream might fail, but it usually succeeds. Let's check it like this. If it succeeds, we will proceed with the corresponding work below. Okay, now because when capturing audio, it needs a place to store the audio data. So here, we need to prepare something to store the audio data. We can see that this data is quite troublesome. We should. So here we place a static array. Let's place two like this. Then these two are respectively where we manipulate this data. We need to initialize this data. From now on, this lock is also used specifically to lock this data. So here, we need to initialize this data. Here, we initialize the data to empty. Then we also initialize this lock. We put this lock together, place it in this position. Okay, good. Then, after we finish triggering here, we need to prepare a method to clear such data. because this thing, before each use, you need to, after using it, we all need to clear it. We need to write this method as a clearing method. Okay. Let's take it one step at a time. This part is a bit tricky. There are quite a lot of these things. Then we basically lock it. After locking is complete, we clear this data. Okay, so after we have this method to clear it, when we close the audio stream, obviously when we close the audio stream, we need to clear this data. Regardless, as long as you call this method, we need to clear its previous data. So when we start audio capture, after we create it, we have successfully created it. Then we also need to handle this. Okay, then at this point, we need to obtain some of our current audio parameters. Right, then we call this method, call this getUEdeliveredInfo method. Then here we need to pass an AudioCapture delivered info. So here we prepare such an AudioCapture, such a struct. We also make this struct static. We put it in the position below. Put it in this position. Okay, good. This is the object of this audio capture. Its parameters. We need to store this parameter here because it is static. So here we need to declare this thing. We declare it on this data. Good. So here we haven't written this method yet, right? Let's write this method next. Actually, because we have already determined that our educapital is success, we can directly call this method inside educapital. Since we are essentially wrapping educapital with our subsystem, this will put the relevant information into this channel. Okay, no issues here. After it gets that, we go back to our place. After coming back here, we need to create a proxy. To bind the proxy, because you can see in the educapital area, there is a method like this called addGenerateDelegate. This method receives. You can take a look at the delegate, and it will reflect such data from our audio and its function signature as TFN, and it looks like this. It's a pointer of this auxiliary type. And then the number of samples. Okay, then obviously, and the handle of the delegate, right? So here we write the handle here, write it below, and as for this method, we also write it below. This method is called, we write it here. So this is the method for generating audio data. Note this audio data. Its streaming is unstable. If you are on PC, it is fixed. But if you are on Android, these numbers, it is unstable streaming. We call it unstable streaming. So it is not fixed. Unstable streaming. For example, on this PC side, it streamed 960. Then on the Android side, it first gives 400, then gives 500, and then gives you 60. So this is unstable streaming. It only ensures the streamed quantity is correct, but the timing of the streaming is not fixed. So this is unstable. I want to emphasize this to everyone. Okay, this is where we receive the audio data, and here when we close it, we remove it. Then here, we need to bind it. This should be this. Okay, after binding it properly, then we can receive the data inside it. Okay, alright. Then at this point, we use the StartCapture method to sample it. And we also need to prepare two parameters to describe the data we will sample in the end. As for these two parameters, we will write them directly, write them as static. Then we call it GetCapture's simple rod. That is how many sample points it needs to sample at one time. Right. And then this is its sampling rate per second. And here, how many floating point data we need to send at one time should be this. Okay, now let's place these two things. Let's initialize it, because we know According to the training flight requirements, this is the requirement. So here, we initialize this thing. We are sampling at 1/6K, and we need to send 640 sample points at a time. Send 640 sample points at a time. Record this data like this. Okay, it seems we haven't copied this pointer yet. Here we need to do a simple copy of it. Okay, and here we also need to set this pointer to null. Okay, and here we also need to call this stop. In any case, when we exit, we all need to turn off this audio. Okay, good. Then we'll stop here for this lesson. Then let's go back and take a look at this. Because there's quite a bit of content here. We might need to add more content later. For now, just make sure everyone absorbs the content from this lesson. Actually, the content of this lesson is quite simple. We mainly wrote about, this is our most commonly used method. There's not much to say about this. Then the singleton object. And these four methods are mainly used to open and close the UObject for our audio capture. Something like that. Then check whether it is currently capturing. This part doesn't seem to have been written yet, so we can do it here. Call this method. This should be CaptureEdu. Now just return it, right? And then this part is to extract the information of AudioCapture from it, because we might need it elsewhere. Okay, so here, now that you have these four things, you must have a U class. This is the U class, right? Then, once you have the U class, on this U class, you can bind a delegate to receive audio data. So this is for receiving audio data. Then the audio data you receive, where do you store it? You need to store it in this TArray. Then, because this TOF involves cross-threading, because this is the audio thread, since it is streamed unstably, it is streamed from the audio thread. So we need to design a lock here. We need to design this lock. Then this thing is obviously, that is, we stored here the attribute of the audio for this painting. And the handle of the joint object here is when we bind this delegate. There is a handle that needs to be bound to this byte when we close the audio in the store. We need to release it, right? And then these parameters have been explained, and this data is the data required by our training flight. So here we make it static because sometimes Junfei requires 6K, but sometimes he requires 8K. Then when you work on other systems, it might require 24K. So sometimes, for convenience, you can't just write it once, this kind of speech recognition, and then rewrite it every time. AudioCaptureSubsystem. So when we later work on sampling point, we can use these two pieces of data to filter the generated data. That's how it works. Mainly used for doing this here. And this is our own pointer, mainly corresponding to this method. Then let's look at them one by one, because this knowledge may not have been covered before. First, this class of ours, we first need to ensure if we have enabled it here, we need to release the previous one. Then if this object exists, we release the previous one. Here we first. Regardless, if it exists by, just close it. Then remove the delegate. Then set the pointer to null. That should be fine. Then clean up this data. When cleaning up the data, we need to add a lock. Then just clean up the data here. After the cleanup is complete, we continue to create our audio object here. We must ensure that this audio object is successfully created. Only then do we proceed further. Actually, a check could be added here. But we didn't add one. It should be fine most of the time. And because we will perform checks externally, so we didn't actually add a check here. Didn't add a check. Actually, you could add one here, because here it's essentially a creation failure. Then the entire system should not work. So giving an assertion is fine. Then after the creation is successful here, clean up the data and store this audio information in our AudioDevice location, because we sometimes need this information when debugging. So it is stored here. Then we bind this delegate, and then at this point, we use this AudioCapture to actually open this audio stream. Because earlier, we were still doing creation and preparation work. And this is to close the audio stream. This is to determine the audio stream capture. Okay, basically, this framework is set up for everyone. Then next, we will plug this data into the host. Right, there are actually many details here. We will talk about this next time. Thank you, everyone.